Seeking English, S.A.T. Workbook, page 455, problem 4. No calculator. It says, in the xy plane, a line given by the equation y equals 33 intersects a parabola given by the equation, and there's the equation, at 2 points, intersects at 2 points. It says that they're A and B, and it asks what is the length of the line AB, meaning if you have these points where the parabola intersects the 33 line for y, there's a distance between them, and they want the distance. They don't even want necessarily the coordinates for those 2 points. If you get those, it's fine, and I'm going to show you how to get those. But part of the value of this video is showing you how to get those 2 points for a similar problem where you have to get those 2 points. Part of the value of this video, I hope, is assuming that you already can do that other part. I'm going to show you why you might not need to do part of it for an extremely similar problem. Okay, you might be able to save a few seconds depending on the problem. But if you spot the answer more quickly and don't have to do the last part that doesn't offer you any useful information, then you can save some time. Okay, and I want to be clear. I'm not teaching you to skip anything as a matter of routine. I'm showing you what you're skipping and how to do what you're skipping. And I'm going to show you how to skip it if you can skip it, when you can skip it. Okay. This doesn't look like an obvious quadratic. I mean, it kind of does, but this 33 is going to throw you off. If we're looking for something that has 33 as a y, then we have to put in 33 as well. There's no way around it. X plus 3, and we're going to find the x's. Okay, minus 16, or we are going to find the x's, but I'm going to show you why we don't need to in this specific case. Okay, so it doesn't look like a quadratic because you don't have a 0. You can easily fix that by moving this 33 over here. Really? Yes. Yes, yes. Okay, from there, I'm going to convert this to x squared plus 6x, okay, plus 9. And it's minus 16 and minus 33 continue. Minus 33. Okay, and you should not need a calculator for that. Okay, should not need a calculator for that. It becomes minus 49 plus 9 becomes minus 40. Okay, and now looks like a quadratic, doesn't it? Okay, good. It means we can just run it through for those solutions. And we will do that. Well, we will and we won't do this. Okay, there we have it. I just need to convert these letters into numbers. Okay, A is a 1, it just vanishes. I always like to go to C first, and I might make a video just about that. I'm gonna take this minus 40, and because the A is already gone, I'm just gonna combine it directly. C directly with that 4. Minus 40 times 4 times minus 4 equals plus 160. Okay, there. B squared, this becomes minus 6. And that becomes 36. 36. Okay, and at this point, you probably wish you could use your calculator because that combines to 196. And if you are a normal student, you may either not know or may have forgotten that the square root of 196 is 14. From there, each of these is reducible by a factor of 2. So that can become, I'll just show it like this. I'll put the 2 over each of them. Okay. Minus 6 becomes minus 3 plus or minus 14 over 2, which is 7. Okay. From there, you can calculate these 2 points. Minus 3 minus 7 is minus 10. Minus 3 plus 7 is 4. Okay. So your coordinates, your solutions for x are x is 10, x is minus 10, y is 33, x is 4, y is 33. And you can run those through and see what they fit. Okay, those are your points, and you can use these to calculate the distance between these is 14, the distance of 14. Okay, and this is the last point that I want to make here, is make sure that you're able to do this. If you're able to do this, then you'll be able to do it when you have to. If you don't have to, then you have the opportunity to not do it. Because this minus 3, it tells you what the position is of these 2 points. But the position doesn't affect the distance. The distance is still going to be the plus 7 and the minus 7 added together. When you see formula for a parabola. When you run a quadratic and you get this plus or minus, those are distances from whatever the vertex coordinate for the x would be, and that's why I've mentioned if it includes I and they cancel each other, then you get a real vertex for an imaginary parabola. Okay, I didn't mention it again. I did. Okay, plus or minus 7 produces the 14. Okay, because the distance between, if you don't account for this minus 3 and just call it 0 for the sake of argument, it's going to be plus 7 here and minus 7 here. All that's happened with the minus 3 is that you've shifted it to the left, and that doesn't affect your answer. It doesn't affect this 14 here, which is the correct answer. And I love this problem, so there's a temptation to continue over-explaining it. I'm not going to do that. See you in the next video.